Okay. So this is now being recorded. Lalabas ko lang yung chat box dito sa gilid. Tapos mag-ano na ako, mag-airplay ako para wait. Yan. Okay. So are we recording now? Nakikita niyo yung red dot?
Yes po, sir.
Okay. Hindi niyo na nga lang ako makikita, or do you see me on the side?
Hindi,
No, sir.
Hindi. Oh, I think I'm gonna be switching on my video para nakikita nyo rin yung buka ng bibig ko kasi minsan di ba nakakatulong yan. Nakikita nyo ako on the side?
Yes po,
Yes,
sir.
Okay, thank you. So, start na tayo. Sorry ha. Kasi nung nag-update yung computer ko medyo nag-iba. Okay. So, today's lesson is about vectors in the three-dimensional space. Lalo na kayo, you are physics majors, I think you are all familiar with vectors. No? Vectors in mathematics and vectors in physics are essentially the same. Yun nga lang sa math, a little bit more abstract in a sense kasi ang vectors sa inyo sa physics are physical quantities. But in mathematics, vectors are a little bit more general. But of course, dun tayo sa physical na representation ng vectors. Kasi that's what it's important to your course. No? For example, in physics, hindi ba? When we say a quantity is a vector, it means to say that it has two components. No? It has both magnitude and direction. Sige nga, can you give me examples of vectors that you have already encountered in physics?
Velocity, sir.
Yan, velocity, no? In contrast, yung speed, hindi, no? Kasi yung speed, siya yung magnitude nung velocity, no? The speed is blind kung anong direction, basta ano lang siya. Yung magnitude lang siya. Wala siyang direction. Normally in physics, no, or in any other course, a vector is pictorially represented by an arrow because an arrow is a very good way to show a magnitude. A magnitude is, well, the length of the vector is represented by the length of the vector and the arrowhead points the direction kung saan nakaturo yung vector or ano yung direction ng vector. Right? On the other hand, when we speak of scalars in physics, we simply mean physical quantities which only has a magnitude but no direction. For example, work. No, I think ang work, di ba, ang work ay scalar quantity. Is that correct?
Yes.
Tama ba ako?
Yes, sir.
Yeah. Ay, mamaya mababanggit natin. May mababanggit tayo tungkol sa work. All right. So because we are working with vectors in R3, no? This is what our operational definition would look like, no? A vector in R3 is simply an ordered tripole of real numbers. It's usually denoted by angle brackets with components A, B, and C. I know in physics that you are using angle brackets differently, no? Yung bra tsaka yung ket, di ba? Tapos yung ganyan. You're using this for inner products pagdating sa mga what do you call this? Mga wave functions, etc. But for our case, yung angle brackets, may tatlong numbers sa loob. Bakit tatlo? Kasi we are in a three-dimensional space. Ang tawag natin dyan sa tatlong components, sa A, B, at C ay mga components. In particular, sometimes to be more specific, yung A yung tinatawag na X component, yung B yung Y component, at yung C yung kanyang Z component. A vector may be represented by any directed line segment or yung tinatawag nating arrow from any point P to the point Q. No, kaya angle bracket ang ginagamit ko kasi I don't want you to confuse a vector with a point, no? Kasi a point in a three-dimensional space, we already represent it by A, B, C, tapos parentheses, di ba? Well, to differentiate a point from a vector, we use angle brackets for vectors and parentheses for points. Okay? Again, so the vector with components A, B, and C is represented geometrically by drawing an arrow from any point P of xy, P, x, y, z. Kunwari, ito yung napili mong starting point. Yung vector mo will be drawn so that from this point, magdodrawing ka ng arrow towards the point Q whose components are, whose coordinates are x plus a, y plus b, z plus c. Okay? And in this case, we indicate this by writing this notation. Pag nakita nyo to, yung PQ, it's a vector with components, mali ito. This is A, B, C. Kita nyo, may mali ka agad ng pagkaka-type si sir. So this is A, B, C. So pwede nyong isipin na ang vector is actually, maybe we can think of a vector as an action. No, an action that acts on the space in a way that it translates, pwede mo isipin na yung point XYZ, it's an action that translates every point XYZ towards x plus a, y plus b, z plus c. So for example, you can think of it as a force, no, that moves the point P towards the point Q with coordinates x plus a, y plus b, z plus c. Yung ABC, ang sinasabi ng mga components ng vector, kung anong i-add mo doon sa initial point para makarating ka doon sa terminal point. Did you understand me so far? Now, because vectors are relative, now when you say relative, pwede ka mag-start kahit saan naman talaga, no? Kapag ang start ng vector mo ay, or yung arrow mo, drawing mo from the origin, of course, the terminal point will then be 0 plus A, 0 plus B, tsaka 0 plus C. That's why the terminal point will be the point with coordinates A, B, and C. In this case, yung vector na ito, it's the same vector as this one kasi it represents the same action on space. No? Magkaiba lang ng geometric representation but it represents the same vectors. Ang pinagkaiba lang ay kaya same vector kasi makikita nyo parehas ng magnitude, parehas din naman ang direction. Did you understand? Kasi kapag vector, ang mahalaga lang naman ay magnitude at direction. Pero specifically, kapag ang tail ng vector nyo ay nilagay natin sa origin, we say that the vector is in standard position. Or sometimes you will see position representation. Sometimes you will read this instead. Okay? Kaya nga yung arrows PQ and OA, no, although they are different geometrically, but as vectors they are considered the same and they are both represented by this vector notation. Kasi parang ano yan eh, parang imagine niyo yung vector instruction. No? For example, nakatira kayo sa isang lugar, no? Let's say, tas may mag-uutos sa lahat ng tao, let's say, move 5 units east in the direction of east and then 2 units in the direction of north. Kung gagawin niyo lahat yon, no? You are all going to be transported somewhere else, no? Pero yung instruction ko, isa lang yung instruction ko, pero kayo may iba-iba kayong terminal point, di ba? So yung vector, parang imagine nyo siya yung instruction that instructs everybody on what to do in the space. Do you understand me so far?
Yes po, sir.
Okay, thank you. Two instructions or two vectors A, B, C, and D, E, F are considered the same as long as the X components are equal, the Y components are equal, and the Z components are equal. In other words, equality is achieved component-wise. Okay? Also, if you are given two distinct points in space, P and Q with coordinates X, Y, Z, and Q with coordinates R, S, and T, then you can calculate the vector or the vector arrow PQ. No? Pag sinulat natin yung PQ, so to calculate this, parang sinasabi mo, ano yung vector na magdadala sa P papunta kay Q? No? Ano yung instruction na kailangan mong iutos kay P para makarating siya dito sa RST? So the answer is, it's the instruction or it's the vector r minus x, s minus y, t minus z. Paano ginagawa? So basically, sinasubtract mo yung mga coordinates ng r minus the coordinates of p. No? Parang pabalik ang subtraction. You see that? Kasi tingnan nyo, pag inad mo na ngayon yung x sa r minus x, ang lalabas r. Pag inad mo yung y sa s minus y, ang lalabas ay s. And so on. So z, pag inad mo yung t minus z, ang magiging final result will be t. Okay? Now, we have the trivial instruction or the zero vector ang tawag natin. Yung zero vector, it is the vector whose components are all zero. So pag ang zero vector ay in-apply natin anywhere on the space R3, ano mangyayari? Nothing will actually happen. No, nobody will move from their positions, respective positions. Do you understand? So this instruction or this vector that doesn't affect anybody in space is called as the zero vector. It's called zero vector kasi zero yung mga components niya. And as for notations, normally we draw arrows above vectors, no? Kaya ang zero vector is represented by 0 with an arrowhead on top. Now, sometimes yung mga textbooks, for me, I choose to use the arrowhead notation instead of the other notation. Yung mga textbooks sa calculus or in some books, they normally use boldface for vectors. Ano ba? Vector V. Ang ginagawa, binobold si V. Ang problema kapag isusulat mo ito sa blackboard or in your notebook, wala tayong paraan to make our fonts bold except meron kang isang pencil na mas makapal, no? Kaya lang that's really inconvenient to use. Kaya ang ginagawa natin to emphasize that a quantity is a vector, we sometimes draw an arrowhead on top of the symbol. Ayan. And also, if the third component of the vector is 0, now let's say ang meron lang first at second component or yung x and y components. Now, we would rather represent that vector by just discarding the third component. Now, yung AB0 will be just denoted by AB. Okay? Do you understand me so far?
Yes po, sir.
Okay. Ano ba yung sasabihin ko tungkol dito? In this case, ang tawag natin dito sa U, no? Sometimes we call this as a plane vector. Kasi parang imaginein mo na yung vector na to ay nagka-act lang on the xy plane. Okay? So for example, we have the following. Let's say the point A has the following coordinates, 2, -3, and 4. B has coordinates 3, -1, and 5. So find the components of the vector arrows AB and the vector arrow BA. Now take note that AB is different from BA. Now because in the vector AB, A is the initial point while B is the terminal point. On the other hand, kapag BA naman, baligtad. Also, let's find the coordinates of the point C such that the vector AC has components 4, -1, and 2. So, paano yan ginagawa? Madali yung number 1, no? Kasi ang instruction, di ba, sinusubtract. So, when you speak of the vector AB, you simply subtract the coordinates of B minus the coordinates of A. So, as you can see, yung 3, -1, 5, ayan. Tapos yung 2, -3, tsaka 4 are here. 2, -3, and 4. So, you simply perform the subtraction. So, you see? Next, the coordinate of the components of the vector BA. So dito baligtad lang ang subtraction. It's going to be the coordinates of A minus the coordinates of B. Laging pabaligtad ha, pabaligtad. So ito yung 2, -3 at 4. Ito naman yung coordinates ng A which are ng B which are 3, -1 at 5. So, subtracting, you should get the following. First of all, what do you notice about these two vectors? Can you comment something?
Same magnitude but opposite direction, sir.
Wala pa naman tayong concept ng magnitude so far. Pero kung mapapansin nyo, yung mga components ng isa are just the negative of the components of the other. No? When you place this or when you represent these vectors as position vectors, when you say position vectors, you put them, the tails, at the origin. Makikita nyo, yun yung sinasabi ni Rex ba? Si Rex ba yung nagsasalita? Sino yung nag-speak?
Si Lou po yat.
Okay.
Opo, sir.
Yun yung sinasabi niya, makikita niyo yung mga vectors na to, when you place them in position representation, they are opposite in direction but the same length or magnitude. So let's see with the point x, y, z. So nasa number 2 na tayo, no? Kasi we're looking for the coordinates of the point C so that the vector AC, alam natin ang coordinates ng A di ba? So that the components of the vector AC are 4, -1, and 2. So paano yun? Dahil si AC ay 4, -1, 2, it meant to say that kapag yung components ng AC na ito ay inadd mo sa mga coordinates ng A, you should be getting the components of C. Kaya nga yung missing na X can be obtained by simply adding this component to the coordinate of A, 2 plus 4, which is 6. Similarly, y should be -3 plus -1, so you get a -4. And z should be 4 plus the component 2, so you get the 6. So C has the following coordinate, 6, -4, 6. I hope that I did my computations correctly. Kapag may mali si sir ng what do you call this, ng computations, please raise it immediately. Kasi sometimes I do make a lot of mistakes. Okay? Can we move on?
Yes po, sir.
Okay. So just like any other objects in mathematics, no, we can combine vectors using operations. Now, there are certain ways to combine vectors together to form another vector, or sometimes a combination of a scalar and a vector, no? So let's say you have two vectors u and v with the respective components. Let's say ang components u1, u2, u3, tapos v1, v2, v3. Right? So we define the sum of the vectors u and v to be the vector whose components are the component sum of the given vector. Anong ibig sabihin nun sa symbols? Ibig sabihin nun, yung pag-add ng dalawang vectors, we do it tapat-tapat. First components to first component, second components to second components, third component to third component. Like so, ganitong vector addition. Okay? Tatandaan nyo, hindi tayo nag-a-add ng points, pero tayo nag-a-add ng vectors. Meron din tayong tinatawag na scalar multiplication. Ano yung scalar multiplication? To perform a scalar multiplication, kailangan mo ng isang scalar, which in mathematics is just a real number, okay? And another vector. So we can multiply a vector by a scalar or a scalar to a vector. So tatandaan nyo, lagi nasa kaliwa yung scalar, nasa kanan yung vector. So how do we do scalar multiplication? We just do it component-wise again. Yung scalar na k, kasi isa lang naman ang component niya, di ba? Yung k lang. Parang dinidistribute mo lang in each of the components. So ganun nakadala ang scalar multiplication. You could also take the negative of a vector. No? So when you say the negative of a vector, it meant to say the vector whose components are the negative of the components of the original vector. At dahil marunong ka ng mag-negative ng vector, you can now perform vector subtraction. You can do u minus v, no? And by u minus v, we actually meant u plus the negative of v. In which case, kapag talagang ginawa mo or you perform this operation, makikita nyo, nagsusubtract ka lang ng, nagsusubtract lang tayo ng components ulit. So parang component-wise subtraction din naman ito. Alright, so technically, subtraction is just addition that involves the negative of the other one. Now, in pictures, this is what happens when we actually do vector addition. Kunwari, ito yung vector u at yan yung vector v. Let's say they act on the same point. Or sa physics, they act on the same body. No? Kunwari, ito yung center of gravity ng isang ano. Ano yung combined effect ng dalawa? Di ba remember, vectors are some kind of effect on the system. No? Uma-affect sila doon sa system. Let's say ito yung center of gravity ng isang body, for example, center of mass niya. And then, let's say, may instruction tayo, iusog mo yung mass na yan pag ganon. Pero iusog mo rin siya, after that, iusog mo siyang ganon. So what will be the combined effect? Now, we can perform addition this way, head-to-tail method or head-to-tail rule. Paano yung head-to-tail rule? You are simply placing the tail of the other to the head of the first one. And then kung nasaan yung head nung pangalawang action, no, doon mo ilalagay yung head nung vector sum. No, yan yung vector na u plus v. So parang imagine yung u plus v, ito yung combined effect nung actions na u and v. But as you can see, this vector is technically the same as this vector. So you can also consider the sum u plus v to be the diagonal of this. Do you see a parallelogram over here? No? Kaya nga ang tawag natin dito sa method na ito ng pag-add ng dalawang vectors, when you place them so that their tails coincide, no? When you use this method, we call this as the parallelogram rule. Kasi you see that this is a parallelogram. And the sum u plus v is actually the diagonal of the parallelogram. On the other hand, when you do scalar multiplications, what actually happens is that if you're multiplying a scalar k that is greater than 1, the action is that it stretches the magnitude of the vector while maintaining the same direction. That happens when k is greater than 1. Of course, when k is less than 1 but positive, nagda-dilate naman into a smaller factor, no? In a factor less than 1. So the vector shortens its magnitude but maintains the same direction. On the other hand, when k is a negative thing, no? Of course, depende dun sa magnitude ng k, but essentially ang ginagawa yan kapag nag-multiply ka ng negative na number sa isang vector, you are changing the direction of the vector to the opposite direction. Kung ano yung length niya, depende yun sa value ng k. Kung malaki yung absolute value ng k, hahaba. Pag mas maliit, edi mas iikli. A special case is when k is negative 1. In this case, ito yung na-observe kanina, no? That u and the scalar multiple ku are opposite of one another. Pero ang isa sa mga noticeable implications is that pareha sila ng length or magnitude. Okay. When k is 0, no? If the scalar is 0 and it gets multiplied to the vector u, anong mangyayari? Ang mangyayari is that, ano ba mangyayari? Magiging kasi ganito. Let's say si u ay may components na u1, u2, u3. Of course, kapag nag-multiply ka ng 0 sa u, yung 0 na to will gets multiplied to every component. Of course, ang lalabas ay all zeros or the zero vector. Nakita nyo yung 0 na to, no? Yung 0 na to walang sombrero, yung 0 na to meron. Because it indicates that this is a scalar, this is the vector. Okay, so we have some more exercises. Let's say you're asked to do 2u plus v whenever you have the following u and v. Number 2, you have 3u minus 5v. So, solutions. So, for 2u plus v, ang ibig sabihin nito, ganyan. Ang ibig sabihin nito, unahin mo munang i-multiply yung 2 doon sa u. Pag minultiply mo si u ng 2, it becomes 8, negative 4 at 2. Then, they will get added together. the result is 6, 0, and 0. Okay, madali lang, no? Pag 3 minus 5V, mali yung pagkakatype na naman ni sir. So this is a V instead of a U. That's going to be 3 times 4, negative 2, 1, minus 5 times negative 2, 4. Mali ito, oh. Gawin ko na nga lang ito ng by hand, ha? Gawin na lang natin to by hand. So V ito. So it's going to be 3 times 4, negative 2, 1, minus 5 times the vector, negative 2, 4, negative 3. Okay, let's do it by hand. So, multiply nyo muna yung 3 dun sa unang vector. So that's going to be 3 times 4 is 12. 3 times negative 2 is negative 6. 3 times 1 is 3. And then, here you have two options. At this point, you have two options. Either you maintain the minus sign here, so magiging subtraction. Tas yung 5 ang i-distribute mo. Or you can do yung negative 5 ang i-distribute mo sa bawat components. Papalitan mo nga lang ng plus yung nasa gitna. So it's up to you. So for example, I decided to just distribute the 5. So I will get a negative 10, a 20, and a negative 15. Tapos isa-subtract ko ngayon. Then I will do subtraction. I will be getting is this a 22? Is that a 22? Hirap naman ang math. And then this is a negative 26. And this is a, tama ba pinaggagawa ko? 18. Did I do it correctly? Guys? Can please somebody confirm on the mic? I cannot see you. Ba't ba ganun wala yun?
I got the same answer, sir.
Okay, thank you very
Same
much.
answer din po.
Okay, thank you very much. So let's move on from here sa next slide. Nakita niyo yung mga operations na to are very well defined. I mean, we are doing the operations basically component-wise. So we're just borrowing the normal number operations, right? Kaya we will expect some nice properties of these operations. So kagaya ng mga properties ng numbers, halimbawa ang vector addition remains commutative, no? Ayan. No? Ang u plus v pareha sa v plus u. And then it also remains associative. Kapag may tatlo kang vectors na i-combine, pwedeng dalawa-dalawa lang. Kahit sinong dalawa ang unahin mo, it will actually give you the same result kung iba naman ang order of operation na gano'n. Basta pare-pares plus yan. Then, kapag yung 0 gets added to any vector, of course, you are expecting the same vector as a result. When you add a vector to its negative, they annihilate to 0. No? Nagka-cancel sila sa one another. No? Parang ito ikaw, tapos ito yung antimatter mo, for example. Nagkita kayo, yan, sasabog kayo. Magdi-disappear na lang kayo, parang ganon. So when you multiply the scalar r to the sum of the vectors u and v, so parang meron pa rin tayong distributive property. No? Oh, in this case, meron kang dalawang scalars, wala silang sombrero. Sila ang inad ko. Minultiply ko sa vector na u, parang nadidistribute pa rin, magiging ru plus su. Ang pinagkaiba na ito dito, sa number 5, ang ina-add ay dalawang vectors. Sa number 6, ang ina-add ay dalawang scalars. Now, isang bagay ang magagawa natin sa scalars na hindi madaling gawin sa mga vectors ay i-multiply. So, pwede tayong mag-multiply ng dalawang scalars as products of two real numbers like this. And then yung resulta, multiply natin sa vector na u. So, you will be getting the following. Pwedeng isa-isa ang pag-multiply, su, tapos tsaka mo sundan ng r. Okay? And then, of course, pag nag-multiply ka ng 1 on any vector, you will get the same vector. Ito na. So, meron na tayo ngayong itong vector norm. Ito yung ating mathematical counterpart ng tinatawag nating magnitude. Kasi yung word na magnitude tsaka direction, they are physical in nature. No? So in order for
Excuse
proper,
po.
what?
Ay, sorry po,
Okay,
sir. May mga classmates po kasi kami na nasa
papasok?
ano po,
Ay, sorry.
nagpapasok.
Okay, so I'm going to,
Wait lang po.
okay, wait lang ha. Pause ko lang muna itong recording. Yan. So ito yung ating mathematical representation ng notion ng magnitude. Okay? Magnitude. So how do we calculate the norm or the length of a vector? You take the squares of the components and then take the square root. For this definition, we have the following remarks or immediate consequences of the definition. As you can see, dahil mga squared quantities yan, they are non-negative even when you take the positive square root. Okay? And the only way for this norm to be zero is when the vector or when the components are all zero, that is when the vector is zero itself. Naintindihan nyo ba? So take note how we're using double bars. So parang instead of, I know that some calculus books uses only a pair of bars like that. Pero for us, para hindi nyo siya ma-confuse sa absolute value, no? Gagawin kong double bars. If k is a scalar, then what is the effect of the product ku, or what is the effect of k to the magnitude or to the norm of the vector? Ang sabi ng property na to, the length of the original vector, ito yung length of the original vector, gets multiplied by a factor of absolute value of k. So, ibig sabihin yan, pag halimbawa sa u minultiply ko ng -2, ang mangyayari, madodouble yung length niya. Kasi ang absolute value ng -2 ay 2. Madali lang naman ang proof niyan. I think we don't even need the proof anymore. Kasi kapag meron kang ku like this, let's say ang u ay may components na ganito, okay? Para ka lang nag-square root ng, ang components mo na kasi ku1, ku2, tsaka ku3. So I hope you can nakakasunod kayo. Bakit ganon? Kasi na-multiply na to ng k. And then, square mo lang, k squared, u1 squared, k squared, u2 squared, k squared, u3 squared. Then you can factor the k squared. You have the following. Okay? And then yung square root ng k squared ay absolute value of k. The absolute value of k. Ito yung norm ng original ng vector na u. So yun yun. Also, if P and Q are points in R3, the distance between P and Q, ito yung distance between P and Q, is technically the same as the magnitude or the length of the vector whose endpoints are P and Q. So parang imagine niyo ito yung P at ito yung Q. Of course, you can have the vector PQ. Okay? Bakit tama yan? Kasi let's say ang P mo, ang coordinates kunwari, x1, y1, z1. Ang Q mo kunwari, x2, y2, z2. Ano ba yung components ng PQ? Ang components ng PQ mo ngayon, mangyayari, so subtract mong ganyan, di ba? Yan, ganyan siya eh. When you take the norm of this vector, you get the square of the square roots. The square roots of the sum of the squares. Like this. O hindi ba, kung papansinin nyo, ito lamang yung tinatawag nating distance formula from between P and Q. Kaya, ganyan. I hope this is kind of clear. So for example, given U and V with the following components, let's calculate the following. So for the norm of U, you just take the square root of the sum of the squares, like so. Okay? Ano bang sagot dyan? 1 plus 16 plus 64. Diyos ko dahil. Hindi ko na alam ito. Ano bang tamang sagot dyan? 1 plus 16, 17 plus 64. Hirap naman ng math. Meron pala yan. 81. So, the square root is 9. Then, what's the norm of V? Square ng 2, negative 2, square ng 9, square ng negative 30, negative 6. So, you get 4 plus 81 plus 36. That is the square root of 121 or 11. Okay? How about the norm of the sum? Ano sabihin ng norm of the sum? I-add muna natin bago kunin yung norm. Pag in-add mo sila, the resulting sum is a negative 1. I hope you can see that. Minsan hindi ko na ginagawa yung mga bagay-bagay. A negative 1, then a 5, then a 2. So you get this. Then take the norm. You have the following. And as you can observe that the resulting sum is 30, so that's the square root of 30. What do you notice here in this example? In this example, what I wanted to tell you is that the norm of the sum is not the same as the sum of the norms. Do you understand? Do you get the message of this example? Anybody? May I see?
Yes, sir. Understood.
Yung message ng example na yon before I continue. Tinanggal ko kasi gusto kong makita yung mga responses nyo. Naintindihan niyo yung message? Tatandaan nyo, pag
Yes po, sir. Yes
ng
po, sir.
example, I do not just give example. Sometimes, this example is to tell you an important message. Now, hindi lang ako basta-basta gumagawa ng example. Now, a special case is really important. This is when the norm of a vector is exactly 1. Or in other words, yung length ng vector mo ay 1 unit. Kaya nga ang tawag sa vector na may length na 1 unit ay unit vector. So for example, the vector negative 1/3, 2/3, negative 2/3 is a unit vector kasi pag kinalculate mo yung norm niyan using the formula, no? Using the formula, what do you get? You get 1/9 plus 4/9 plus 4/9. Okay? And the answer is 9/9 or 1. Sa physics, we have the following important unit vectors. No, sometimes ito yung I, J, K na vectors na tinatawag niya sa physics. Pag sinusulat natin yung vector na I hat, no? I hat ang basa ko dyan eh. Kasi yung sombrero niya ay hat ang basa dyan. It is the vector 1, 0, 0. J is the vector 0, 1, 0. And K is the vector 0, 0, 1. So you can check that these vectors are actually unit vectors kasi pag in-square mo yung mga components niyan, tapos in-add mo, kinuha mo yung square root, the answer will be 1. Now, in standard position, ano itsura nila? In standard position, this is how they may appear. No? So for example, ito yung X, ito yung Y, ito yung Z. Kung in standard position, when I say standard position, yung tail ay nasa origin, bibilang ka ng 1 unit sa X direction, yun yung I hat. 1 unit sa Y direction, yun yung J hat. Yung 1 unit sa Z direction, yun yung vector na K hat. Did you understand? Notice that if you have an ordinary vector U1, U2, U3, no, you may find that you can actually write U as a sum of 3 vectors as shown, U1, 0, 0, plus 0, U2, 0, plus 0, 0, U3. No? Tama ba yan? Tama ba yung decomposition ko? And then, itong first vector na U1, 0, 0, you could actually factor out the U1. What lives here is 1, 0, 0. Dito factor out mo yung U2, magkakaroon ka ng 0, 1, 0. Factor out mo yung U3, magkakaroon ka ng 0, 0, 1. And it turned out, ito na yung I, J, at saka yung K. This is why sometimes vectors in R3 are represented using the IJK notations. Now, sometimes, especially sa physics, I think this is the more preferred way to write a vector. So kapag nakakita kayo ng 2i hat plus 3j hat minus 5k hat, ang ibig sabihin talaga natin yan, it's the vector with components 2, 3, negative 5. Advantage kasi yan kapag halimbawa, walang z component. Let's say, lang, yan. Mas maikli, no? 2i hat plus 3j hat. It meant to say 2, 3, 0. Did you understand? This is just for notations because sometimes I also use this. There will be times that I will be using that. And it's an advantage to use that sometimes. Ay, teka lang. Did I already tell you bakit ganun yung formula ng norm or magnitude ng vector? Kasi kapag nilagay mo yung vector in in position representation. So nasan yung tail? Yung tail ay nasa origin. Okay? Tas yung vector u mo na ang components ay u1, u2, u3. Ang terminal point niya ay nasa point na u1, u2, u3 kapag ang ginamit mong representation ay position representation. So in order to get the magnitude or the length of this, anong gagawin nyo? So you're going to get the distance between u1, u2, u3 from the origin. And that distance is the square root of u1 squared plus u2 squared plus u3 squared using the distance formula. So I think that's it. Now sometimes it's an important task, no? Sa math or sa physics, no? Kapag meron kang non-zero vector v, no? Non-zero vector v, you would, of course, a non-zero vector v will specify not only a magnitude but also a direction. Now sometimes in that particular direction, we wanted to know the unit vector that points in that direction, no? How do we get that? So you can consider the following operation. Na pag nakita niyo yung v divided by, nakakatawa, divided by, nag-divide ka ng vector by a scalar. It's not allowed, pero ang ibig sabihin lang talaga ng nag-divide ka by a scalar, you're multiplying the vector v with the reciprocal of its norm. No? When you look at this, this is going to be a vector, a unit vector in the same direction as v. Why is it in the same direction as v? Kasi multiple lang siya ng v. And the question is, why is it unit? The idea is that kapag kinuha mo kasi yung norm nung vector na ito, sabi ko nga, as per definition, ito lang talaga yan. Pag kumuha ka ng norm ng k times u, di ba, sabi natin kanina, lumalabas yung scalar pero may absolute value. Tapos kinukuha mo lang yung norm ng v. Kaya lang norm ito, ang mga norms never naman naging negative. Kaya ganyan lang yan. And eventually magka-cancel ito because v is not 0, this is not 0, you can cancel them out. So the answer is 1. So this proves that whenever you divide a vector by its magnitude, what you are getting is a vector of length 1 that points in the same direction. So for example, you're given the vector v with components 1, negative 4, the square root of 3. Let's find the unit vector u which is in the same direction as v. O yan, kunwari ganun ang tanong. Anong gagawin nyo? Kailangan yung malaman yung magnitude ng v by taking the norm. So this is me taking the norm of v. Square root of 1 squared plus negative 4 squared plus the square root of 3 squared. You get square root of 1 plus 16 plus 3. I think that's the square root of 20 or 2 square root of 5. Now, ang gagawin ko, yung scalar na 2 square root of 5, ipang-divide ko yan sa lahat ng components. When I do that, 1 over 2 square root of 5, minultiply ko doon sa vector na 1, negative 4 square root of 3, I will be getting this as a result. May nawala na naman dito. Diyos ko, day. Ano nawala? Yan. Pag ginawa nyo ito, this resulting vector is going to be a unit vector. O kung gusto nyong nira-rationalize yung denominator, kanya-kanyang trip yan, no? Bahala kayo. But this of course will suffice for me, no? Unless sinabi ko na rationalize the denominator. Kaya may something ako dun sa operation, kaya hindi ko nire-require mga estudyante ko to do that. No? So this is a unit vector. I forgot to mention, this is a unit vector in the direction or parallel to V. Kapag sinabi nating parallel, in the same direction as V. Did you understand? May tanong ba? Do you have question before I proceed? Wala
None
naman.
so far, sir.
Madali lang, no? Oh. Ay, ano nangyari? Okay, so let's proceed. Next. We are now going to talk about another type of operation, which is called as the dot product. Now, how do we do the dot product of two vectors? Kasi diba, ang meron addition of vectors, scalar multiplication. But we haven't yet taken product of vectors, pero pang paraan to multiply vectors. Now, I don't want to call this vector multiplication because it's really not. No? Bakit it's not? Kasi, first of all, on that product, when you do that product of two vectors, the result is a scalar. That's one thing about the dot product that one of the reasons why I do not consider that products as a multiplication. Kasi ang inputs mo mga vectors pero ang output mo ay isang scalar. Paano ginagawa ang dot product? Ganito, you multiply the components, component-wise, yung mga products, i-add mo. O di ba ginagawa niyo operation na yan ng paulit-ulit sa iba't ibang aspeto ng buhay niyo, di ba? Hindi lang naman dito. As an example, halimbawa, bumili ka ng 1 kilo of rice. The price of 1 kilo of rice is kunwari 50 pesos. Yung isang bar ng detergent soap, kunwari 30 pesos. Tapos yung isang lata ng sardinas, kunwari 20 pesos. How much would 3 kilos of rice, 2 bars of detergent soap, and 6 cans of sardines would cost, no? Ito yung mga pagkakataon na kayo ay nagda-dot product pero hindi nyo alam na dot product ang tawag doon. Do you agree? Kasi tignan nyo. Kapag ginawa mong U, yung unit price vector, anong unit price vector mo? 50, 30, 20. 50 represents the unit price of the rice, 30 for the soap, and 20 for the can of sardines. And si Q naman yung quantity vector, which is the vector that represents the amount or the number of items na bibilin mo per item, 3, 2, and 6. 3 for the rice, 2 for the detergent soap, and 6 for the sardines. Then the total cost is calculated using this dot product. Do you realize that that is a dot product? Hindi. Pero at least ngayon, alam nyo na yan ay isang example ng dot product. Paano sir kapag hindi lang tatlo yung bibilhin ko? Let's say bibili ako ng 10 produkto. Ayan. This is the reason why in mathematics, we even study dimensions greater than 3. No? Kasi dito sa calculus natin we are most of the time confined with the three-dimensional space kasi meron tayong tatlong spatial dimensions, di ba? Pero sa abstractly or in a more abstract manner, it can extend up to a number of dimension, right? This is one of the reasons why we have to study them, not because of the geometry of it, but because of its applicability to certain areas. For example, sa economics, etc. Na hindi lang siya sa physics ina-apply, marami rin pinagagamitan ng mga vectors. So for example, yung mga variables nyo sa statistics, halimbawa nag-survey ka ng 50 students, tapos meron kang questionnaire. Halimbawa, ang isa sa mga tanong, kunwari, ang isa sa mga variable mo, sex, kundi male or female. O kunwari, 1 kapag male, 0 kapag female. Yung 50 na students mo, pag nagsagot, for example, no, yung variable na sex, it's a vector with 50 components. Ang components no, kundi 1, 0. Kumbara, it's a sequence of 1, 0, 1, 0, 0, 0, 1. So it's a 50-dimensional vector. Did you understand? Oh, let's put this into yan. Let's say you're given the following vectors or data, u, v, and w. So you're going to calculate the dot of u with the sum of v plus w. So ang gagawin nyo, i-add nyo muna yung v and w together. So when they are added together, it gives you -2, 3, and -8. So when you take the dot, anong dot? -4, -15, and -8. So that's -27. Tama ba? I think so. How about u dot v, the sum of u dot v and u dot w? Tatandaan nyo, pagka kayo'y nag-dot product, ang final answer ay scalar. Okay? Ito, scalar plus scalar. So the final answer is also scalar. The dot product mo muna bago ka mag-add. So anong dot product na ito? 2 minus 10 minus 4. Ito naman, -6 minus 5 minus 4. So there you have it. Okay? So the answer is -27. All right? So let's take the properties of dot product. So kagaya ng ibang operation, meron din siya mga natural properties that we would like to mention because they will be of use. Ang dot product na u dot v, parehas lang daw sa dot product na v dot u. Kasi real ang mga components natin. Pag complex na yan, naku, iba. Pero tsaka, wag na nating usapan yun. Real numbers muna tayo. Ang dot product ay symmetric, parang u dot v is v dot u. Number 2, it also distributes over addition. Right? So kahit ang dot product mo nandito sa kanan, it will also distribute because meron ka nung property number 1. Number 3, if you take the dot of a vector with a scalar multiple of another vector, the resulting answer should be the same as the scalar factor k times the original dot product of the two vectors. Pwede mong isipin na ganito yan eh. Halimbawa, ito yung unit price vector mo. Ito yung quantity vector. Let's say, bumili ka ng products na yon for a particular recipe. Thinking na 4 lang kayong kakain. No, tumawag yung nanay mo habang nasa grocery ka. Anak, doblehin mo na yung bibilin mo kasi may darating tayong 4 na bisita. So ang gagawin mo, ito times 2 mo yung quantity vector kasi kailangan mo bumili ng twice as much. In the end, ang nangyari, yung price na babayaran mo will be 2 times as much din, syempre. Naintindihan niya? One of the ways you can imagine or you can think about that products. No? Syempre, pag dinoble mo yung quantity ng bibilin mo, madadoble rin yung presyo. Do you understand?
Yes po, sir.
Naintindihan niyo ang
Yes
aking
po, sir.
analogy? Okay. So, let's continue. Pasensya na kayo, on off ko ha, kasi this is the only way I can see your responses. Parang sa number, wag na natin gawin yan. In number 4 naman, what will happen if you take the dot of a vector with itself? So, para ka may u1, u2, u3, idadot mo sa sarili niya. May sagot na kasi no? Pag dinat mo yan, magiging u1 squared plus u2 squared plus u3 squared. So kung mapapansin nyo, this is something familiar. this is like the norm except without the square root. Kasi ang katotohanan, siya yung square nung norm ni u. Tatandaan nyo to ha, when you take the dot of a vector with itself, the answer is the square of the norm. Sir, hindi ba u squared? Hindi. Hindi ko kayo tinuruang mag-square ng vector. Huwag kayong magpauso. Okay? Kasi wala naman tayong vector multiplication in the first place. Okay? Huwag niyong gagawin yung u squared ng walang norm. Kasi, kaya ito valid kasi ang ini-square mo ay yung norm ng u. Ibig sabihin, nag-square ka lang ng number. Again, ang u.u ay hindi u squared. Instead, it's the square of the norm of u. Therefore, ang u.u cannot be negative. Okay ba? O halimbawa, meron tayong expression like u plus v dot w plus x. How would you apply these properties to properly multiply, take the dot product of this? Well, first, you can think of u plus v as a single vector. Maybe you could think of it as a vector A. And then, i-distribute mo itong as a whole sa bawat isa, magiging ganito. And then, apply ka ulit ng dot product, madidistribute mo naman ito sa bawat isa. So, what we just did is the so-called, ang tawag dito, FOIL. Naalala niyo ba yung FOIL method, no? In other words, in mathematics, wherever may distributive laws, no? Wherever nag-hold ang distributive laws, normally yung FOIL method ay nag-a-apply. Ito yung F, ito yung nagkabaligtad nga lang, naging FIOL. It doesn't matter kasi ang addition naman ay commutative. Did you understand? So whenever distributive property is applicable in a situation, normally the FOIL method will be there to help you. Oh, next concept. Kapag meron kang dalawang vectors, we would like to see how dependent is one from the other. Ano yung sabihin ng dependent is one from the other? Pag kasi parallel lang sila, when I say parallel, they are just on one is just a multiple of the other. Madali lang yun. Mako-compute mo isa yung gamit yung isa. But when they are not parallel, there are different degrees of being not parallel, no? Different degrees. Pwedeng ganitong itsura nyo, pwedeng ganitong itsura nyo, hindi kayo parallel, pwedeng ganitong itsura nyo, no? No? May iba't ibang degree ng pagiging hindi parallel or paano ba? Kung natin yung gawin, yan. And to measure that degree of unparallelness, no? Ini-introduce natin yung concept of the angle between vectors. In other words, yung degree of independence ng dalawang vectors by using angles. Now, let theta from 0 to pi. So, ang angle natin will be from 0 to 180 degrees only, ha? Kung yung gusto nyo gawin degrees, 0 to 180. But in calculus, remember, always set your calculators kung kayo gagamit into the radian mode. Lagi tayo naka-radians sa calculus. Kasi we consider angles as real numbers. Okay? So kung lumagpas man ng 180 kagaya nito, hindi mo na siya i-measure in this manner. I-measure mo na siya in this manner instead. Okay? Kaya para yung angle natin will just be from 0 to 180. So parang ganyan ang ating physical idea when we speak of the angle theta between u and v. Okay? Now take note that this vector is basically u minus v. Why? Kasi 'di ba pag inad mo yung v sa u minus v, ano lalabas? 'Di ba u? Ayan no. Pag inad mo si v sa u minus v, para ka lang nag-isip ng i-add mo sa v para ang sagot ay magiging u. Ang sagot ay u minus v. So using these three vectors, makikita nyo makaka-form ka ng triangle. And this triangle has sides of length norm u, norm v, tsaka norm ng u minus v. Tapos let's say this is the theta. Okay? Now at this point, I'm going to use the so-called cosine law from trigonometry or the law of cosine. So if three sides of the triangle are given and one angle, we can relate these three sides and this angle using the cosine law. Sabi, the square of the side opposite the given angle is equal to the sum of the squares of the other two sides minus, may defect value ka. Ito yung defect. Ito yung defect. Ano yung defect? Twice the product of the lengths of the sides that include the angle times the cosine of the angle. Ang tawag nyo dito ay cosine law. Tatandaan nyo, ang cosine law, para ma-remember nyo, general case lang ito ng Pythagorean theorem. Ito yung Pythagorean theorem mo, just in case that the angle is not right. Kasi kapag tingnan nyo, pag yung angle ay right, when your angle is right, ito yung theta mo, 90 degrees or pi over 2 kasi nasa calculus tayo. O di ba? Ang Pythagorean theorem mo ganyan. Ang totoo niyan, meron niyang defect term. Nagkataon lang, ang cosine kasi ng pi over 2 is just 0. Kaya hindi na siya nasusulat. You understand? Always remember, ang cosine law ay extension lang ng Pythagorean theorem just in case that the angle is not 90. No? Alright, so this is the cosine law. Remember, ang interest natin dito yung angle. So ang gagawin ko, isa-solve ko yung cosine theta. So there. So ang ginawa ko lang ay nag-algebra. Sinolve ko lang yung cosine theta. Anyway, yung mga vectors naman na to ay non-zero. Kasi kapag isa dyan ay zero, hindi natin ma-define yung angle. Diba? So non-zero. So this is very legal. Now this is legal. Okay. Anong gagawin natin? Ang gagawin ko, I will look at this term and I'm going to use the properties that we have listed a while ago. Yung square nung norm, nung vector na ito, remember, ang property talaga ay ito. V dot V is norm ng V squared. So, kapag in-square mo yung norm ng U minus V, it's U minus V dotted with itself. O ano namang ginawa ni Sir dito? Ang ginawa ko next dito, nag-foil. And then, I found out that because U dot V is just the same as V dot U, yung O tsaka yung I, they will be combined into one. Magiging 2 times U dot V, like so. Plus norm ng V squared. Okay. Now imagine this being placed over here. Ano mangyayari? Itong 3 terms na to will be placed over there. What will happen? Oh my gosh. These 2 will cancel out. These 2 will cancel out. This negative will eventually cancel with that negative. Ang may iwanan sa taas will be 2 times the dot of U and V. No? Tapos yung mga negative mawala. Di ba? Then you can cancel the 2. And there we have a formula not for the angle but for the cosine of the angle. And because theta simply ranges from 0 to pi, you can just calculate theta by simply taking the arc cosine. No? Alternatively, you can alternatively, if you really want an explicit formula for theta, you can basically get the arc cosine of this expression, should you wish to get that. Okay, paano pinipindot sa calculator ito? Ito yung cosine na may negative 1 sa ibabaw. Okay? There we have the following observations. Kapag yung theta ay acute, less than 90 degrees. Anong value ng cosine theta sa first quadrant? Di ba sa first quadrant, itong cosine ay positive. Di ba? Positive sa first quadrant. Kaya yung right hand side mo positive. Eh yung denominator mo, lagi naman yung positive. So therefore, it implies that the dot product is positive. Kapag naman yung theta mo ay saktong 90 degrees, 90 degrees to, 0 to. Eh kung 0 to, that meant to say that u dot v is 0. Paano pag obtuse? Mali ito. Tanggalin natin to. Paano pag obtuse? Lagpas ng 90. Well, ang cosine mo that time is negative. Eh kung positive palagi yung denominator, that meant to say that the numerator is negative. In other words, kapag pala kayo ay nagda-dot product ng dalawang vectors, ang dinidescribe ng dot product is pretty much the angle between the two vectors. Kapag ang dot product ay positive, it meant to say that the angle between the two vectors is acute. Pag ang dot product ay 0, it meant that the, what? Basta non-zero si u and v, ha? It meant to say that u and v are perpendicular to each other. And when the dot product is negative, that meant to say that the two vectors are of angle greater than 90 degrees between them. Or obtuse yung angle sa pagitan nila. Naintindihan niyo ba ako? So whenever you're doing dot product, remember that you are trying to describe how wide is the angle between them. Is it obtuse? Is it right? Or is it acute? It depends on the sign of the dot product. So binibigyan ito ng katuturan yung pagko-compute nyo ng dot product. Bakit tayo nagko-compute ng dot product? It is because we wanted to describe how wide the angle is between two vectors. Do you understand me so far?
Yes po, sir.
Okay, I want to see responses. Okay, thank you. So let's go back. Ang hirap nang hindi ko kayo nakikita talaga. Yan. Consider the triangle whose vertices are A, B, and C as shown. We want to determine the degree measure of the interior angles of the triangle. So let's say you wanted to measure the angles within the triangle. So what do you want? How do you want to measure that? Of course, hindi ka magpa-plot ng mga points nito sa three-dimensional coordinate system natin. Tapos kukuha ka ng protractor, no? Palulutangin mo sa space yung triangle mo. It's not very easy to do that, no? 'Di ba? Gagawa ka ng actual model, mag-replicate ka ng three-dimensional coordinate system, tapos ipa-plot mo yung mga points, gagawa ka ng triangle na made of kung paano nyo man i-engineer yun. That's very engineer kapag ginawa niyo yun. But of course, we have a very convenient mathematical formula to actually measure the angles without actually measuring, which is the cosine formula. What you do, ang strategy is the following. So meron kang triangle like this, A, B, C. Let's say you wanted to measure angle A. Ang gagawin ko, I will look at the vector AB and the vector AC. And then I'm going to get the angle between AB and AC. And then the angle between AB and AC, if that is theta, for example, then theta is going to be the arc cosine of AB dot AC divided by the norm, the product of the norms of AB and AC. Did you understand? That's my strategy. So, kukumpitin ko yung AB. There. Kukumpitin ko rin yung AC. And there you have it. Ano yung measure ng angle A? that's included between AB and AC, that's the inverse cosine or the what do you call this? The arc cosine of the following using the cosine formula. Now you can just perform the dot product and the norms, blah 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 blah, and yan. No, I hope that my computations are correct. No, kung mapapansin nyo, hindi ito special na cosine. So when that is the case, you can just use your scientific calculators to actually compute the arc cosine. Pag hindi sakto yung cosine. Pero kung sakto, ba lumabas square root of 3/2. That means something else, no? Pwede nyo kunin yung value ng theta exactly. Alright? So this is the measure of the angle A. How about the measure of angle B? So kukunin mo yung mga vectors that includes B as the angle. Ito yung BA, kukunin ko rin yung BC. Similarly, ito yung measure ng angle B using the cosine formula. So I will do the same calculation and compute the measure of angle B as follows. Okay? Paano mo na ngayon kukunin yung measure ng angle C? You can proceed as usual. Kunin mo yung CA tsaka CB. Pero may isang method na mas madali. Alam mo na kasi yung angle A, alam mo na yung angle B. Paano mo kukunin yung measure ng angle C? You can just use the fact that the sum of these angles is 180 degrees. By the way, nakalagay dito degree measure. So don't forget to switch your calculator in degrees mode. But by default, remember, we should always use the radian. There. So this is the relationship between the measure of the angles of the triangle. So you can calculate it as 47.0358 degrees. Did you understand? So I think, ayan, in pictures, ayan yung positions ng A, B, and Z. May almost 90 degrees yan, no? Ito. Lagpas ng 94 degrees yata around, nasan ba yun? Ayan, no? Yung angle B, ang almost 90 degrees. 94 actually. So yan yung kanilang itsura. Alright. So meron tayong mga certain inequalities that needs to be talked about. Especially, for example, yung Cauchy-Schwarz inequality. This is very much useful. In algebraic sense, parang ganito yan eh. Halimbawa, ang U mo ay U1, U2, U3. Tapos ang V mo, kunwari, V1, V2, at V3. Ano sinasabi ng Cauchy-Schwarz inequality? Ano basahin? Cauchy-Schwarz. Kombinasyon ng French tsaka ng isang German na mathematician. Actually, may pangatlo pa yan eh. Isang Russian. Cauchy-Schwarz, ano bang pangalan ng isa? Bunyakovsky. I forgot. Kasi yung inequalities na to ay may iba't ibang version and being used differently. May tatlong mathematicians na nagsulat tungkol dito or nakilala tungkol dito. They are Cauchy-Schwarz and the Russian mathematician, whatever, no? Nakalimutan ko. Pero normally, Cauchy-Schwarz lang siya talaga sa mga libro. Kawawa naman yung Russian, no? Just because he's Russian. O, tingnan natin. Ano yung U.V? Ang U.V parang ano yan eh. U1, V1, U2, V2, U3, V3. Lagyan mo pa ng absolute value. Kasi pwedeng ano yan eh. Tatandaan nyo, pwedeng positive to pwedeng negative. So regardless of sign, hindi yan lalagpas sa square root ng U1 squared, U2 squared, U3 squared, times the square root of V1 squared. Alternatively, pag ini-square mo both sides, pwede mo sabihin na yung square nun dot product, yung square na ito, hindi lalagpas sa product ng mga sum of squares. Ganyan siya in a purely algebraic manner, no? Ganyan siya in a purely algebraic manner. Pero geometrically, what does it say? It says that the dot product, regardless of sign, cannot exceed the product of the magnitude or the length of the corresponding vector. Or even better, for me, this is how I understand the Cauchy-Schwarz inequality as a message. It tells us that if two vectors are short, when you say short, their magnitudes are small, of course, this product will be small. The thing is, as a consequence, the dot product will be even smaller. Sa Tagalog, hindi pwede magkaroon ng malaking dot product ang dalawang vectors na maikli. Nakita nyo? Tatandaan nyo, remember, in mathematics, when you have a theorem, it is not just a theorem just because it's a theorem, no? Laging ang mga theorems, kaya yan binibigyan ng pangalan because it has a message to relay. It is up to the readers on how to interpret it. Bahala kayo. Ako, when I was a student, I have my own ways to make sense of the theorems in mathematics. Kasi sometimes when you just look at the theorems as formulas or as inequalities, they kind of they tend to get boring, no? Minsan mahirap tandaan. It is because wala kang hindi mo naiintindihan kung anong mensahe. But when you come to understand kung ano yung totoong mensahe ng theorem, it becomes wonderful. It becomes beautiful. Kasi imaginein mo, how can a set of symbols send a message to you? That's the beauty of mathematics. So how do we prove the inequality? Well, tignan nyo, if one of the vectors is 0, we are done already. Alam nyo bakit? Pag isa dito ay 0, sabihin na natin sa U, yung left-hand side mo 0. Yung right-hand side mo, 0 na to regardless of the size of V. Kaya, trivially true yung theorem kapag isa sa U or sa V ay 0. Okay? So for the rest of the proof, let's assume that U and V are both not 0. Okay? Pag hindi sila 0, anong meron? Aha. We can consider the angle between them. So let's consider the angle theta between U and V, which is measured from 0 to pi. Then using the cosine formula, we get to have the following, right? And then I can solve the dot product as this. I will take the absolute value of both sides because the inequality involves the absolute value of the dot. Ito naman, pag in absolute value mo, mga norms na yan. So they don't need absolute values anymore. Ang kailangan na lang natin ng absolute value yung cosine kasi ang cosine could be negative in this range. In particular, sa second quadrant, negative ang cosine. But remember in trigonometry, kahit na pa iba-iba yung value ng cosine from 0 to pi, no? Mag-start yan sa 1 tapos bababa sa 0, sa 90 degrees, tapos pagdating sa 180 degrees, babalik ulit sa negative, bababa sa negative 1. Ang cosine, never siyang lalagpas sa 1. Di ba? Kaya kung ito'y less than or equal to 1, ibig sabihin yung product na ito, less than or equal dito. Times 1. But that is just the norm. And that's the Cauchy-Schwarz inequality right away. It relied on the fact that the value of the cosine of theta cannot exceed 1 in absolute value. Were you able to follow the argument? Anybody could please speak? Yes? Okay.
Yes.
Let's go back. We only have 20 minutes remaining. But I still have how many more slides? A lot of slides. Dami pa. Tingnan natin. As a consequence to this, as a consequence of the Cauchy-Schwarz inequality, is what we call as the triangle inequality. A while ago, I mentioned something about the norm of the sum and the sum of the norm. So Using an example, I was able to illustrate that these two quantities are not necessarily equal. Alright? Nako, ang ingay ng barangay namin, may announcement. Naririnig nyo ba? Or hindi naman?
Medyo mahina naman po, sir.
Okay. Thank you. Nasaan na sila yung mic na malakas? So, sabi neto, if the sum of the norms is not the same as the norm of the sum, laging mas malaki raw ang sum of the norms. Bakit ito triangle inequality? Kasi it talks about something about triangles, a property of a triangle. Kasi pag ito yung U, at ito yung V, ano yung U plus V? Di ba ito ang U plus V? Di ba? So, ito yung length nitong triangle na to, norm ng U plus V. Yung length nito, norm ng U. Ito, norm ng V. Ang sabi nito, when you add two sides of a triangle, it's always bigger than the third side. Tandaan nyo yun ha. If you have a triangle, you add two of the sides, the sum is always greater than the third side. In geometry, that's the triangle inequality. But in calculus or in our subject, this is how we represent the triangle inequality. And this is the reason why it's called the triangle inequality. Kasi nasabi nito, kung hindi man sila equal, kung di man, mas malaki lagi yung sum ng mga norms over the norm of the sums. Okay ba? So how do we prove the triangle inequality? Well, alam nyo, I could not just start with this and then end up less than or equal to that. Kasi pag sinulat mo yun na ito, dead end na yan. Wala ka na magagawa dyan. Ang gagawin ko, look at this. Instead, I will begin not with the norm, but with the square of the norm. Kasi kapag in-square ko yung norm, I know something about this one. Sabi natin kanina, that's the product of the dot product of U plus V with itself. And when I have something like this, I can apply the FOIL. I can do this. No? Ano nangyari, sir? Naku, U dot U. Naku, ginawa mong U square. Masasampal kita. Butin lang, di face to face. No? Ang U dot U ay norm ng U squared. Hindi siya U squared kasi wala tayong square ng vector. No? Tama ba? Oh, yung last terms, V dot V, naging norm ng V squared. Eh yung O tsaka yung I, ay parehas yun eh, di ba? U dot V parehas yun, kahit na V dot U equal sila. Times 2 kasi dalawa. Alright? Now here, itong U dot V, i-apply ko ngayon yung Cauchy-Schwarz inequality. Ano sabi ng Cauchy-Schwarz inequality? Yung U dot V, regardless of the sign, cannot exceed the product of the norms. There. Now, what I have here is now something in the form of a squared plus 2ab plus b squared, which we know from algebra is the sum of the square of a and b. A and b here are real numbers because they are norms. Yan. Because the square of this norm is less than or equal to the square of the sum of the norms, then, dahil non-negative yung mga bagay na to, it follows that the norm of U plus V is less than or equal to the sum of the norms. Okay? That's a triangle inequality. What's next? Oh, this is some kind of an application, no? In physics, alam nyo, ang calculus naman talaga, tatandaan nyo, ang calculus, although it's a very big part of mathematics, although you can study calculus independent of physics, yun ang ano ngayon, di ba? Yun yung drama. Pero in reality, the way the world developed calculus is through the problems in physics. Kaya lang naman nagawa yung calculus na yan kasi may mga problems tayo sa physics that needed to be solved. So gumawa tayo ng mga tools in order to answer the questions in physics. Hanggang yumabong na lang ng yumabong yung mathematics, naging more abstract. Tapos feeling ano na ang math, no? Gano'n na lang. Pero ang katotohanan niya, nanggaling naman talaga sa physics yung mga mathematics na meron, karamihan sa mga mathematics na meron tayo nowadays. Kasi ang palalabasin natin nowadays na yung physics ay application ng math. No? Parang in reality, that's very baligtad. Kasi in history talaga or historically, talagang ang calculus ay inimbento for the sake na mapag-aralan ang mga problems or magkaroon ng proper language of physics. In physics, the work W, which is a scalar, done by a force F that acts on an object or a body producing a displacement D vector is given by the dot product of F dot D. Bakit dot product? Let me explain this formula. With a particular problem. Let's say a wagon or wagon ba? Ano bang basa dyan? Is pulled at a distance of 50 meters along a horizontal path by a constant force. Ito yung mahalaga, no? Yung force na ina-apply ay constant. Kasi later on, mapapag-aralan natin paano computing yung work when the force applied is variable. Paiba-iba. Kapag variable yung force, pero continuously variable, you can use a line integral to measure the work. But for constant forces, ganyan. The handle of the wagon is held at an angle of 45 degrees above the horizontal. Find the work done by the force. So I think I have an illustration here. Yung mga physics, diba tinuruan ko kayo mag-latex, mag-drawing ng mga ganyan. Ayan, you can apply. So pwedeng imagine niyo yung wagon, ito yung paghila natin, 45 degrees above the horizontal. It produces this displacement. Pag sinabing distance of 50 meters is horizontal path lang naman, yung magnitude ng displacement na ito, in this case hindi laging totoo. Kasi yung distance is not always the magnitude of the displacement. No? Nangyayari lang yun pag straight yung path. Pero pag curvilinear na yung motion, they are no longer the same. So we will be talking about that later. So ito ay 50 meters. So, ang work is F dot D. Naalala niyo yung cosine formula? Yung cosine formula is U dot V, norm U, norm V. Kaya ang U dot V, there's another way to write U dot V. It's the product of the norms times the cosine of the angle. Kaya you can write it also this way. Alam niyo ano nire-represent ng norm ng F? Yung norm ng F, ito siya. Diba? Anong nire-represent nito? Anong nire-represent niyan? Ay, mali ako. Let me rearrange this. Ito yan eh. Norm F cosine theta. Ang pagpe-pairing ko itong dalawa, tapos ihihiwalay ko yung norm ng D. Yung norm ng D, ito yun. 50 meters. Right? Yung norm F times cosine of theta, what does that represent? It actually represents this using trigonometry. If you take the cosine of 45 degrees, no? If you take the cosine of 45 degrees, multiply it to the hypotenuse. Di ba ang cosine ay adjacent over hypotenuse. So when you multiply the hypotenuse with the cosine, you get the adjacent. So you are multiplying this length, na ito yun eh, ito. Medyo iba yung color ha. Itong portion na yan, yung length niyan, yan yung norm F cosine theta. So in reality, ang minumultiply talaga natin when we're doing work problems like this, it is the component of the force relative to this direction or relative to the vector D. Ito yun, no? Kung ano yung component niya parallel to the motion of the body. Kumbaga ano yung portion niya na naka-affect do sa body causing it to move in this direction. Naintindihan niyo? Yun yung mini-measure nito. Times the 50 meters. Kaya nga ang lalabas dyan, 60 times 50 times the cosine of 45, ang work done is 1,500 square root of 2 Newton meter. Ano bang Newton meter? Ano bang tawag nyo dyan sa physics? 1 Newton meter is?
I think joules, sir, if I'm not mistaken.
Joules ba? Hindi rin ako sure kasi hindi man ako nagtuturo ng physics.
Yes, sir. That's
Joules ba?
Yes, sir.
Yeah. So, ganun yan. At a given angle. So, ang minomultiply talaga natin, di ba kapag sinabi nyo work is force times distance, ganun siya in ano eh. Pag i-explain mo yung work sa mga simpleng nilalang or sa mga simpleng tao, it's the force times the distance. But actually, pag sinabi nyong force doon, it's the net force in the direction of the motion. Kaya ang kinukuha natin, yung component ng F in the direction of the displacement. Na ito yung minomultiply natin with the total distance traveled. Naintindihan nyo? Hindi yung magnitude talaga ng force. No. Okay? That's why the work is also, ito yung general na formula, F dot D. Unfortunately, sa mga standard na physics problems, hindi mo naman alam yung components o yung vector components ng F, hindi mo na alam yung vector components ng displacement. Unless you have a given that madaling computin, dot product lang. But for problems like this, you have to convert it into something else para ma-realize na talagang tama yung F dot D. No? Meron tayong proper language to talk about this. Ang tawag dyan ay vector projection. Yung portion ng vector mo or yung component ng vector mo in the direction of a given vector, you call that the vector projection of V onto you. Parang hinahanap mo yung anino, yung shadow ni V onto you. Onto you. Intindihan niyo? Onto you. And this is what happens when the dot product is positive. When you say dot product is positive, pag acute yung angle. But if u dot V is negative, the angle is now obtuse. No, na obtuse. This is obtuse. This is greater than 90. No? Ang projection mo is opposite that of u. Kasi yung anino mo ay naroroon sa kabila. Naintindihan nyo? May tanong ako. What will happen to the vector projection when u dot V is 0? Kasi wala dyan sa options di ba? When u dot V is 0 or 90 degrees yung u and V, anong itsura ng projection ni V onto u? Ha? Anybody?
Sir, pataas. Charot.
Tama, pataas. Pataas yung ano mo, ito. Pataas yung V. Tapos ang U mo ay ganito. Anong itsura ng projection mo? Anong itsura ng anino mo? Anong itsura ng anino?
Parang dot or line lang.
Dot lang. Or in other words, the projection is just the zero vector. Di ba meron tayong paraan to represent that? It's the zero vector. Very good. Ibig sabihin kapag halimbawa, yung force na in-apply mo ay perpendicular dun sa direction ng motion, may work ba na nagawa yung force na yon doon? Wala, di ba? Zero. Kasi ang dot product ay zero. Pag yung F ay perpendicular doon sa displacement, ang dot product kasi ay zero, kaya zero ang work. Anyway, paano kino-compute yung projection? 155 na at this time. Pero di bale. Tingnan natin. Paano kino-compute yung orange na vector? Yun yung tanong natin. If there's one thing that we should realize is that the projection vector is parallel to the vector u. It's either in the direction of u or opposite the direction of u. Naintindihan niyo? Dalawa lang pwedeng mangyari. Well, alam natin that the unit vector in the direction of u is given by u divided by the norm of u. Kanina yan, di ba? So, kapag minultiply ko yung u, well, gaano ba kahaba yung projection muna? Ano yung sinasabi ni Sir na magnitude of the projection? Paano naging ganito to? ginamit ko yung formula na cosine theta is adjacent over hypotenuse. Kasi tignan natin yung drawing. Dito na lang sa drawing na to. Ito yung hypotenuse. Ito yung theta. Okay? To get this, ito yung adjacent. To get the adjacent, how do you get the adjacent? Cosine theta is adjacent over hypotenuse. Therefore, adjacent is hypotenuse times the cosine of theta. Kaya ito yung formula. Ito yung hypotenuse, ito yung cosine of theta. This is the length of the adjacent side of theta. So kung ganito kahaba yung projection, at ito yung unit vector in the direction of u, saan equal ito? Paano mahanap yung projection vector? Ito yung gawin mo, i-dilate mo or i-multiply mo itong unit vector na to with this factor. Kasi yung factor na to, ang magsasabi kung gaano kahaba yung projection. Diba? Ito yung unit direction, ito yung magnitude. So multiply mo, yun yung vector na vector projection. Yan, pag minultiply ko. Now maybe I could somehow play around with this formula ng ginawa ni Sir. Pinagdugtong pero nagdagdag ako ng isang more mu sa taas para maging square yung nasa ilalim. Ba't ko naman ginawa yun? No? Anong karapatan ko doing that? Well, I can do that because I'm your teacher. But maliban doon, ang reason talaga yung numerator para maging ganito. Kasi I know that this expression is exactly the same as v dot u using the cosine formula. And therefore, you have this as the formula for the projection vector. Now, ang tanong, sinong pino-project mo kanino? Si v papunta kay u. Anino ni v ang nasa u? Kaya v dot u over norm nung u squared. Tapos times u. Bakit times u? Kasi parallel nga sa u ang projection. Tatandaan nyo. Kung nag-project ka sa u, ang projection ay multiple lang ng u. Gaano kahaba? Ito yung magsasabi. Now, do you have to memorize this formula? Yes, unfortunately. But take note, you can also write v dot u as u dot v if you want. But basta tatandaan nyo, kung ano yung nasa denominator, doon mo pinoproject at kung ano yung nandito. Kung pinoject mo naman sa v, instead, si u ang pinoject mo sa v, paano mo papalitan yung formula? Gagawin mo lang v ito, gagawin mo lang din v yun. Unfortunately, there's no easy way but to just memorize this formula. Now, last na. I'd like to say that the projection vector is, of course, as for its construction, it's parallel to u. This is harder to prove, but ano ba natin to i-illustrate? So, let's say ito si u, ito si v. So where's the vector projection? The vector projection is like this. Ito yung projection vector ni v onto u. Ang tanong ko, nasa na si v minus the projection? Paano pag sinubtract ko yung v tsaka yung projection? Minus projection. Para mong ina-add yung paano ba yun? V minus projection, saan may kakabit yun? Okay. So maybe we could represent it this way. Pag ganito, pataas. Yeah. Kasi kapag in-add mo ito, tsaka ito, ang lalabas si V. Di ba? Nakita nyo ba? Yung V minus the projection, which is the red vector, is going to be perpendicular to you. Kasi siya yung second leg nung right triangle. No? Tama? Nakita niya? Or pwede nyo rin i-represent this way. The idea is, ito yung idea. Ito si V, mahati mo siya into two parts. No? Ano yung two parts? Nahirapan akong pumili ng color. Projection nung V onto U plus ano yung other part? Yung isang part, V minus the projection. So let me use di ba ganyan yan? The idea is I was able to split or decompose V as a sum of one vector which is parallel to U and another vector which is perpendicular to U. Ang tawag dito yung mga orthogonal components ng V onto U. Anyway, you were able to decompose V as a sum of two vectors so that these vectors are, one is parallel to U, the other is perpendicular to U. So meron ako exercise sa inyo, sasagutan natin to next time. 2:00 na kasi, I'm so sorry. Medyo nag-extend kasi nag-ayos tayo no? We will solve this next meeting, pero ayan, may pencil, paki-screenshot, para ready na kayo. Na next week, i-check natin kung tama yung sagot. This is an exercise. Calculate the projection of V onto U and the projection of U onto V given the following U and V. Please take a screenshot if you want. No? Exercise natin ito ha. Ito yung ungraded. Okay, may isa pa. Ito yung maganda. Ito yung isa pa. Okay? Write the vector U as a sum of a vector parallel to V and the vector orthogonal to V. Nakalimutan ko sabihin to. I'm so sorry. The word orthogonal means perpendicular. Okay? Or much more, parang ang U dot V ay 0. Sabihin U and V are orthogonal. Perpendicular sa geometry. Hahatiin mo daw si U into two parts so that one part is parallel to V, the other part is going to be orthogonal to V. So marami pa tayong di-discuss. We will just continue next meeting. So I'm going to stop sharing at this point. Where's my mouse? Saan mouse ko? Ayun. Okay, I would like to stop this recording.